Welcome to today's Explainer. Today, we're tearing down something pretty cool. We are looking at the Kintsugi FastAPI stack. Basically, this is a production-grade, full-stack media sharing app, and it's built to mimic the glory days of early Instagram. We're going to go straight under the hood to see exactly how it handles things like auth, feeds, and secure media uploads. Here's our roadmap for the breakdown. 1. The web's hidden engine. 2. Anatomy of an API. 3. Securing user data. And 4. Managing app content. All right, kicking things off with Section 1, the web's hidden engine. Now, we all know the front end is what users actually interact with, right? But the real heavy lifting, that happens backstage. The API is basically our back-end framework running on a secure server. Think of it as the central nervous system that's managing user accounts, images, and video posts. It's literally the invisible engine powering our whole Kintsugi photo sharing app. It handles all that complex data safely out of sight. So when you swipe to refresh, your feed instantly populates with the latest media without you ever having to think about the routing happening behind the scenes. Moving right along to Section 2, Anatomy of an API. Let's actually break down the URLs that route all this traffic. First, we have the domain, which is our server's main address. Then, the path, or endpoint, routes us to the specific resource we want. And finally, those query parameters pass along extra super granular instructions to that endpoint. And all of this creates a continuous communication loop. The front-end client fires off a request to the back-end API server. Then, the server processes it and fires a response right back. It's just a rapid-fire, endless conversation. So, what's actually in those packets? Well, an outgoing request packs a method, a path, a body containing the data, and headers for extra context. The returning response is pretty similar, but it swaps out the method and path for the all-important status code. And honestly, those status codes are the ultimate vibe check for your app. Seeing a 200 means success. Everything is great. 400s, like the dreaded 404, mean the client messed up somewhere. And the 500s? Yeah, that's a server error. That means the engine broke and it's officially a bad day for the back-end dev. Okay, on to Section 3, Securing User Data. Think of the server as a strict bouncer at an exclusive club. When a request rolls up trying to delete a post or view a private feed, how does the bouncer know it's really you? I mean, it needs rock-solid verification. Enter JSON Web Tokens, or JWTs. Instead of demanding a username and password for every single photo you like, the server hands you a stateless token. This token basically becomes your digital VIP pass for the entire session. Here's the exact life cycle of how that works. The user hits the auth endpoint with their login credentials. The server verifies those, generates a signed JWT, and sends it back for the browser to store. From then on, every single new request carries that JWT. This allows the server to instantly verify the signature and just process the request without asking for a password again. So to quickly summarize Kintsugi's security loop, Step 1, provide credentials to the auth endpoint. Step 2, store the signed JWT securely in the browser. And Step 3, verify that signature on all future requests. Pretty straightforward, right? Finally, Section 4, Managing App Content. We map all these interactions out using standard CRUD operations. Get retrieves data, post creates it, put updates it, and delete, well, removes it. It's basically the universal language of content management. And here is the actual blueprint of Kintsugi. This is our FastAPI Swagger UI. It's an interactive, auto-generated dashboard of literally every endpoint. Notice the super clean organization here. We've got an auth block for logins, a users block, and our default block, which handles all the heavy lifting of feeds and uploads. So let's actually test the engine. We execute a GET request on the posts endpoint. Boom! Server response gives us a 200 OK. And inside that response body, we get a pristine JSON object with an ID, our new post title, and the content itself. Everything is wired up perfectly. Now, to create content, we just switch to a post method on the post endpoint. We pass our title and content right into a JSON request body. Upon execution, the API ingests this data and commits it safely to the application's database. But obviously, an Instagram clone needs media, not just text, right? So check out our post upload endpoint. The request body type is specifically set to multi-part form data. This is absolutely crucial. It's the exact mechanism that lets our backend securely accept raw image and video files straight from the client.
Bringing it all together now, we hit the get, feed, endpoint. But look closely at the headers. There's our authorization header carrying our bearer JWT. Because we flash the bouncer our VIP pass, we get a 200 OK and a rich JSON payload full of image URLs and captions to instantly populate the user's feed.
Wow, we've covered some serious ground today. From URL routing and stateless JWT security to watching FastAPI handle raw media uploads. So I'll leave you with this. What kind of application will you build now that you hold the actual blueprint to a production-grade API? The engine is yours to command. Thanks for hanging out with me on this explainer, and keep building.